Elon Musk, also known as the real-life Iron Man, proposed this idea about Hyperloop in 2013. According to his proposal, the train would travel from LA to San Francisco in half an hour, while a flight usually takes a little more than an hour. So, what makes the train so fast? The answer is, the train is a type of Maglev train, or magnetic levitation train, and it floats above the air. In other words, the train has no direct contact with the guideway. But what makes it float? We have to look at two physical laws to understand this. First, Faraday's law states that change in magnetic flux will induce a current in the coil, while Lenz's law tells us that the induced current will flow to oppose the change. For example, here the magnet is moved closer to the solenoid, so the solenoid will experience a stronger magnetic field going this way. To oppose the change, the current will flow in such a way that according to right-hand rule, the induced magnetic field will go in this way, so that the two magnetic fields are in opposite direction. And what's really neat about this property is that we see here two like poles are near each other and there will be a repulsion force. In this case, it's North Pole and North Pole together, and they will repel each other. This will be really useful for engineers to create the levitation. For example, if the capsule or the train acts as the North Pole and the rail also acts as the North Pole, they will repel each other. And if the repulsion force is strong enough to cancel out the gravitational force, the train will float. So now we know that the train floats. How about on horizontal axis? What makes it move? From the free body diagram, we see that although there's no friction with solid, there is still aerodynamic drag or air resistance since the train is traveling in air. And here comes the brilliant part about Hyperloop. Musk proposed to have the train in an almost vacuum tube so that even the air resistance is minimized. And according to Newton's first law, the train would tend to maintain its initial velocity without resistance. This means that little propulsion is needed since everything is pretty much just inertial movement. Because little propulsion is needed, Hyperloop will save a lot of energy. Other advantages include self-power. You can use the solar panel from Tesla, energy because it's electricity, and also negligible air pollution and sound pollution. Given all these advantages, will Hyperloop become a vital part of our future transportation? Let's wait and see.